Okay, in this problem, we're given the distribution of potential stock prices. It's a binomial option pricing model. It says today's stock price is 30. 1 month from now, it will go up to 34 or down to 26. If it goes up to 34, then the following month it will be 39 or 31. If it goes down to 36 after 1 month, then the following month it will be either 21 or 31. The risk-free rate is 1% per month. How much should you be willing to pay for a call option with strike price of 32 and expiration 2 months? So it says construct the binomial tree and also make sure you show your calculations of delta and B at each node. Actually, I don't have to do it quite at each node, but so I kind of set this up for you. You can see there's the binomial tree. It goes up to 34, down to 26 after 1 month, and then if it goes up to 34, it goes up to if at 34, then, well, anyway, you can see that S's conform to the question. First step is to figure out what the call option is worth at expirations. So after 2 months, if the stock price is 39, the call option with a strike of 32 would be worth 39 minus 22 is 7. This exercise value would be 7. If, on the other hand, it ends up at 31, that's less than the strike price of 32, so, you know, why would you exercise your right to buy at 32 when you could buy for 31 in the open market? You wouldn't, so it's not exercised there. Likewise, if it falls all the way down to 21, the call option would not be exercised, so their value is 0 at expiration at those 2 points, at those 2 nodes. So, and actually, this is the easiest to look at right here. If we're going back to C down, if the stock price goes from 30 down to 26 after 1 month, we can see that there's no chance of it being exercised given, you know, our distribution. It has 0 value regardless, so therefore the call option is effectively worth nothing at that point. But up here it's a little more interesting, and here we have the potential of exercise for positive payoff. So we need to figure out this call C sub u. So first thing we do is calculate the delta for this node. Delta is defined as, you know, call up, or, you know, the change in the call price divided by the change in the stock price. That's 39 minus 31 is the change in the stock price. 7 minus 0 is a change in the call price. So here's our calculation, and we get a delta of 7/8. Now we can use that delta to solve for B. If we use and we have the choice, we can actually use this data or this. If we go up, if you use this data, we say call up would be delta 1 times S up plus B1. That would, rearranging that would give us B1 is call up, which is 7, minus the delta we just calculated, 7/8 times S up, which is 39. We could also have used that node, this node here. That is, or, I guess, using this node, we'd have B1 equal to, what would that be, 0 minus 7/8 of 31, using that data right there. Either way, you get the same answer, actually, if you work it out. So actually, I'm going to use this number, so that's because I don't have to use a calculator quite yet. So 7/8, so it's negative 7/8 of times 31. Fine. And now we use that and go ahead and calculate. We can use that to get this, because C up is, well, that delta 1, S up, plus the B1 we just calculated. So that's going to be, delta 1 we said is 7/8, so it's 7/8 times the S up is 34, plus B. B we just said is negative 7/8 of 31. Right? I'm sorry. So that's 7/8 times 34 minus 31, basically. Oh, I'm sorry, I forgot about the time value. Excuse me. B, I should put this, I'm sorry. It's delta 1 S up plus B1 e to the minus RT, which in this case, so that's going to give us minus 7/8 times, what is that, 34 minus, we had 7/8 of 31 e to the minus 0.01. R is 0.01 per month, so T is 1 month. Okay, so that's our call up. And that gives us, well, I guess I could rewrite it a little, simplify it a little bit. That's 7/8 times what? 34 minus 31 e to the negative 0.01. If you want to simplify it, so that, I think that comes out to 2.894898, if I did that right. So let's put that here, 2.89. Now, if this were an American option, you would check that against this exercise value, which, you know, S minus K is 34 minus 32 is 2, and indeed it is greater than, this is greater than 2, therefore it checks. It's a European option, so we don't need to do that. Now we can finally get down to here. We have all the blanks filled in. Excuse me. So again, we have to calculate a delta. So we're going to call this delta 0. Delta 0 is C up minus C down over S up minus S down, which is, we had 2.89 divided by S up minus S down is 34 minus 26, which is, of course, 8. That gives us 0.361862 if I don't round off at all. And now we can calculate the B, or CD rather. You can use up or down. I choose the down one. Like I said, you can use either node, C up or C down. C down would be delta naught S down plus, we'll call this B naught. Rearranging, we get B naught equals, let's see, call down is 0, and the delta we just calculated is 0.36 and change, 3618. 36 times the S down is 26, times 26. And that gives us negative 9.40. Well, 9.408419 is actually, if you don't round off. Now we can take that number and calculate what we're looking for. C naught is delta naught plus times S naught plus B naught in present value. So that's, let's see, delta naught we said was 0.36, so that's going to be 0.36 times S naught was 30, the original stock price was 30, so that's delta S. And then we have it's negative B, 9.4084 e to the negative 0.01, that's our T is 0.01. And that gives us, C naught is 1.5410 and etc. So basically, to the nearest penny, $1.54 will be the value of our call option at time 0.